Yep, all good.
Alright. Hey all, welcome to our talk today about the recent fractureiser malware infection that impacted the Minecraft modding community. This talk will be structured as a chronological timeline of events, detailing the process of discovery, analysis, and the eventual mitigation. We'll also go over the social aspect of organizing and coordinating a large malware mitigation effort, and leave some time for questions afterwards.
Before we start discussing the timeline and events, let's talk about the people behind the mitigation team and the tools that we use throughout the process. Going down the list first, we have me. I originally started the research into the malware, and I was key in coordinating and organizing it.
We have me, who helped with coordinating and organizing on the IRC and wrote the decompiler that the majority of us used.
In addition, we have Unescribed, who helped with IRC management and coordination, as well as the documentation of the various behaviors in the malware. We have Willie Willis, who played a major role in documenting the timeline of events and maintaining the GitHub repository, where all information was stored. And last but not least, we have Vazkey, who, unlike the rest, was not a reverse engineer on the project, but was responsible for public communications, spreading helpful information about the status of the malware, how to check if you're infected, infographics, and things like that. This is, of course, not an exhaustive list. We've linked the full credits page below, if you want to see further.
Yeah. As for the tools, the major ones we used were Recaf, Vineflower, and Internet Relay Chat, also known as IRC. Recaf is a bytecode editor and analyzer that comes with built-in deobfuscation tools, which was helpful in the analysis of obfuscated code that we encountered. Recaf was created by Kali, a later team member. We also had Vineflower, a modern Java decompiler, which was used to analyze jars, both obfuscated and deobfuscated. Vineflower is maintained by me. Finally, IRC, specifically Esper.net, was used as a common chat platform for communication and coordination. IRC has the benefit of not needing an account to join channels and being minimal, allowing for rapid communication. These tools helped us significantly throughout the process and such deserve some special mention.
The start of our story today is how most of us got alerted to the situation. Luna Pixel Studios discovered that their CurseForge projects were uploaded to without their knowledge, and had their files archived so that they wouldn't show up in the web UI, but would still be available for updates in the launcher. This was fairly suspicious, as all the members on the team had two-factor authentication enabled, so a warning was posted in the fear that a vulnerability within CurseForge was being exploited, or malicious files were being uploaded to their site, potentially both. I was there initially at the time, and grabbed a copy of the files and began working and trying to figure out what's going on, in addition to informing other guilds and groups of people in the process.
Obviously, the first thing to do when you encounter a mod that might be infectious is to download and start poking at it, right? If you were able to download one of these jars while they were still up, you would have seen a typical mod, except for this curious addition to the mod initializer shown here. Even glancing at it, the code sticks out like a sore thumb. It's creating new strings manually using byte arrays and is using reflection to invoke methods instead of directly calling them. That is not the type of code that one is typical to write, and warrants some further inspection as to what it's doing. While the code looks convoluted, it's fairly simple to piece back together. You can map the numbers back to their respective letters and put the string back together, or you could copy the string into a separate Java program and print it out to the console, revealing what it says. Either way, you'll get code that's easier to understand. Let's look at what it looks like deobfuscated.
This is a lot more concise. We can see that it's using the class URL class loader and constructing it with a URL and with a given IP, port, and path. With that information, it's downloading Java code from the internet, finding a method called run in the utility class, and invoking it with what seems to be like another IP. This is weird. Why would your mod be connecting to the internet to download another class file? While we didn't know the full extent at the time, this is not even a dozen lines of code and is setting into motion a sequence of events that attempts to infect your computer with the full case of fractureiser. We ended up calling this portion of the infection process Stage 0, as it's the stage that users would download and put into their system knowingly. A stage, in this context, is a distinct piece of malware that is downloaded and executed on a user's computer. The stages count upwards, with each stage being downloaded by the previous one. It is worth noting how humble Fractureiser's beginnings are here. With just a few lines, it's able to download and run arbitrary code, hidden in a place that many would never think to look. Unless you had a snitch firewall or similar running on your system, you would never really know that the Minecraft mod you just downloaded was downloading extra code from the internet. The next logical step, of course, is to ask where the downloaded code is going, what it's doing, and grabbing a copy of that to take a look.
Yeah. Stage 1, the way that it's retrieved by the preceding stage 0, is never actually saved onto your system. It's downloaded, executed, and garbage collected, all without leaving a trace. On June 6th, when we were first looking into this, the static IP that served stage 1 data was still up and active. Using other means of downloading, such as curl, allows you to download the file and put it on your disk, making it easier to reverse engineer. This stage contains more code than the last, and is not possible to show it all in one go, but we will be discussing its functions and behaviors. Stage 1 is not obfuscated, even in the slightest, and even leaves the local variable names intact in the jar file. This makes it easy to understand what it's doing, as essentially it's just all there in plain sight. This seems like a fairly big oversight, but it makes some sense considering that stage 0 doesn't store stage 1 to disk anywhere, where one might decompile it. However, the IP that provides stage 1 doesn't have any authorization protocol in place, so you could just download it by putting the URL in your browser, for example. As for behaviors, stage 1 serves roughly the same purpose as stage 0, being another vector for another jars to be downloaded and executed. However, the author included a contingency. If the same IP used by stage 0 is unable to be contacted, it connects to a static URL hard-coded inside of the stage 1 jar to reveal the real IP that it should connect to. This has the effect of allowing the author to swap out IPs on a single site, potentially allowing new infections to continue even if specific IP addresses go dark. The connection protocol here is, in fact, obfuscated, consisting of a knocking sequence, where small sequences of data are sent to and from the infected computer to the command and control server. This makes it more difficult to casually obtain a copy of the subsequent stage without decompiling and understanding the stage 1 code. When the subsequent stage 2 does get downloaded, it is saved to disk with an otherwise unassuming name. On Linux, this is called lib.jar, and on Windows, this is called libwebgl64.jar.
Another notable behavior of Stage 1 is that it attempts to set the newly downloaded Stage 2 file to execute itself on startup, along with eventually running it directly. This is achieved by, on Linux, using systemctl, and on Windows, using the registry. However, on Linux, this is very likely to fail, as most users are not running with superuser access, and the command would query the user for process escalation. On Windows, this is much more likely to succeed, as the Windows reg.exe allows the user to edit their own user-specific keys without needing administrator approval to do so, allowing Stage 1 to silently set up Stage 2 to execute every time your computer starts.
So far, we've discussed the malware itself as one may have found on the first day, and the code that makes it work. However, as the hours passed, it quickly became clear that the situation was a lot more complicated than we originally imagined, and a coordinated approach would have to be taken. As the largest source of infected files, Lunapixel Studios was a fairly popular member of the modding scene. Multiple Discord guilds and groups of people began to work on research and reverse engineering at the same time. Emmy, who did a large part of the initial decompilation and research, mentioned offhandedly that there's no collective place to share information organized and suggest making an IRC channel. I thought this was fairly amusing and made a channel on esper.net called CF Malware, as at the time we were still unsure if this was an auto-updater, a backdoor into CurseForge, or something else. A lot of the people doing reverse engineering up until then quickly joined the IRC channel and collaboration started. Top of our minds was the fact that we had all managed to obtain a copy of Stage 0 and Stage 1, but no one had managed to find a copy of Stage 2 yet. At this point, we decided to start a collaborative technical analysis document to put research and analysis into one place. The initial version of this document was housed on the platform Snopita, but it would quickly move to HackMD for better access control.
Stage 2 proved to be elusive, even with knocking with the protocol that was specified in the first jar. It seemed like the file and the server was simply down. How would we proceed? After a while of searching, the enigmatic Guest 35 joined the IRC channel, claiming to work at a host company. And with them, they provided a copy of the Linux lib.jar that was supposedly infected on one of their servers. After this, the reverse engineers on the IRC channel quickly started initial analysis, and found that the sample looked on the surface to be heavily obfuscated. It was obfuscated with aleatory, making analysis through decompilation alone quite difficult. However, the aleatory obfuscator has multiple levels of obfuscation, and the members of the IRC managed to find a deobfuscator that was able to clean up the obfuscated code into something that was at least readable. Obfuscation is an information-destroying process, and it's not usually possible to restore a class file to its original state using a deobfuscator, especially without losing information. However, with the amount of eyes on the deobfuscated code, we were quickly able to piece together what it was doing.
About this time is when the command and control server hosting Stage 1's files got taken down, so no known versions of Stage 0 could propagate to Stage 1. As Stage 0 infections, we discovered, only contained a hard-coded IP address. If that IP were to go dark, the entire mechanism of infection, starting with Stage 0, would be deactivated. One of the members of the IRC managed to get in contact with the hosting company in charge of the IP address, and they got the address null routed very promptly. Around this time is also when the unofficial Discord guild was created, permanently dividing organization efforts and communication between those who stayed on the IRC and those who migrated to the Discord guild. This ended up making coordination between the two difficult, as people now had to shuffle information between the IRC channel and the Discord guild. As the organizers, this duty fell on us primarily, and a lot of time following this was spent moving data and making sure everyone was in the know with the current situation. Had this not had happened, the mitigation effort likely would have been smoother overall.
Here's an example of Stage 2's obfuscation, as run through the Vineflower decompiler. Values are reordered on the stack, and string literals are obfuscated to hide their true value. However, with the use of deobfuscation, the stack values can be restored for the most part, and the obfuscated strings can be statically resolved. Using these tricks, we can look at what Stage 2 is doing. Like the stages before it, Stage 2 downloads another payload and saves it to your computer. The protocol to download Stage 3 also has a knocking process that was used for the Stage 2 download, but with one minor difference. Instead of sending a 1 to the instance, a 0 is sent this time instead. At the end of the process, as far as we know, Stage 3 would have been downloaded. Unfortunately, no one working on reverse engineering managed to get a hold of Stage 3 at this point, so this is all we knew. This is because Stage 2 and Stage 3 were hosted at the exact same address.
While working on analysis of the method that contains the Stage 3 payload, we found this string in the main method of the jar. This is fairly amusing by itself, as it means the malware authors used the demo version of a well-researched obfuscator to hide the workings of code that was poised to infect thousands of users. The version displayed is also important to note, as version 8.5 of the aleatory obfuscator was released on March 1st of this year, putting a date to the earliest possible time that the malware could have been obfuscated.
Up until this point, we were not able to find a full copy of Stage 3 to analyze. Some keen eyes on the IRC realized that fractureiser was uploaded to the malware aggregation site VirusTotal, which performed some of its own analysis on downloaded files. It contained executables and network connections. Obtaining samples from VirusTotal is not a simple process, as you need to be vetted by the site itself, which makes the process more involved than simply clicking a button. However, someone with the appropriate credentials found their way into our channels and managed to send us a highly mangled and truncated version of Stage 3. This gave us some insight into what it was doing, but we would need the full code to see what it was actually doing. Thankfully, this was much easier than we had originally thought it would be.
someone on the Discord guild happened to have a full copy of Stage 3, and after a wormhole to the team, proper analysis of it was able to start. Wait, we need to hold up for a second. How did this person manage to find a full copy of Stage 3, the thing they've been searching without success for the past few hours? Apparently, they had been infected over a week ago and used that opportunity to conduct research about the malware and its behaviors. This research proved to be helpful for our documentation, and of course, the sample they sent was incredibly helpful. As for Stage 3, even with the unmangled jar file, analysis took longer than expected because of the obfuscation in play, like Stage 2. However, unlike the preceding stages, there's a lot of de-obfuscated code here, significantly more than the other stages, which slowed down our analysis of it. The native library in question, helpfully named hook.dll, looked like a standard DLL except for two JNI methods named retrieve clipboard files and retrieve MSA credentials. So that was exciting. This was also the first stage that doesn't have a clear place where it downloads another stage, so it looked like it was doing something different. After a run through the obfuscator replaced string literals and the hint from the DLL file, it became clear that Stage 3 exists to steal as much data as it can find. So what is it stealing? In addition to the MSA tokens and the clipboard contents mentioned before, it seems to have code to steal browser cookies, crypto wallets, Discord credentials, Microsoft credentials, and more. This supports the idea that this is the end of the stage pipeline, and its goal is to transfer sensitive information back to the command and control server instead of downloading more stages. There's also code here that references DDoSing and escaping VMs, but these seem like red herrings. We have no way of knowing if the DDoS behavior functioned due to the command and control server being taken down, and the VM escape code seems to be entirely smoke and mirrors, as it seems unlikely that the malware authors would burn a potentially catastrophic VM escape vulnerability on something intended to infect Minecraft mods. So this is already pretty bad, as it tries to steal your data and transfer it to the attackers. However, while looking through the classes, we accidentally stumbled upon the true nature of Stage 3 and what makes it so insidious.
We discovered that the goal of Stage 3 is to find every jar in your system that is available and attempt to put Stage 0 inside of it. There is special handling for Fabric mods, Forge mods, Spigot plugins, and Bungee Cord plugins to inject it into the mod initializer, and there is additionally extra functionality to put it in certain places in vanilla Minecraft jars. If this is not available, it'll simply put it in the main class of the jar. If you were to have an active Stage 3 infection on your computer, potentially every mod you have installed in any Minecraft instance, including vanilla Minecraft that you have downloaded, could become infected with Stage 0. If those mods were to be transferred out of the system, shared with others as a mod pack, or uploaded to mod distribution platforms, it could then begin the infection process on whoever downloaded the files next. This means that fractureiser is indeed a worm and a virus, instead of a simple piece of malware. In addition, if a Maven repository had gotten infected with this by a mod author manually uploading the infected files, then it could have potentially silently infected anyone who downloaded the jar, living inside the modder's Gradle caches, which most people don't frequently, if at all, inspect. Of course, there's no point in speculating on motives for this. It at least feels like the attacker must have had some knowledge about the infrastructure of the modded Minecraft ecosystem to be able to weaponize the trust users put in modders and use it for malice. As a somewhat unrelated aside, once we realized what was going on, the IP address for the command and control server pointed at by the static URL changed in a bid to continue the infections, and ended up serving a completely deobfuscated version of Stage 3 for about 45 minutes. This didn't end up helping as much as you probably would expect, as we had already fairly thoroughly combed through the mechanically deobfuscated code, as we had been given at least 8 hours. But it was helpful to concretely pin down what it was doing, and was also fairly hilarious.
So just to recap what all the stages are doing, since there's 4 of them and it's fairly easy to get lost. From the top, Stage 0 is typically a jar that you download from a mod hosting site or such. It serves to download Stage 1. Stage 1, which is not saved to disk, downloads Stage 2 and tells it to run whenever you start your computer, or at least it tries. Stage 2 is safe to disk, and it downloads Stage 3. Stage 3 is a complex piece of malware that steals your data and also creates more copies of Stage 0 by infecting jars on your system.
Let's talk about documentation. Around this time is when we migrated to GitHub for the documentation from HackMD. HackMD provided good access control, but only 3 people were allowed to edit at a given time. This meant all the changes to the docs had to get funneled through dedicated journalists, which ended up becoming a very time-consuming task. In addition, the HackMD web interface struggled to render the document properly with so many people viewing the doc, making edits time-consuming and eventually impossible. The GitHub happened primarily to fix the latter issue, but it became clear that this was the way to go from the start. There was some concern about PR churn slowing down the iterative process of releasing documentation, but this meant people could write concurrently and get reviews from administrators, significantly improving the quality of the document. We thought that live editing would have been a good idea at the start, but it ended up becoming a hassle to remove misinformation and prevent griefing. The addition of access control and improved stability proved that GitHub was the right choice in the end, and we should have used it from the beginning. So, how did Lunapixel Studios get compromised? We were speculating at the beginning that perhaps CurseForge had been exploited and there was a backdoor there, but that does not seem to be the case. As far as we know, a Lunapixel Studios dev downloaded and ran a copy of fractureiser, which contained Stage 0, and this eventually would progress to Stage 3 on their system. From there, the attacker obtained all the information that fractureiser can steal: their cookies, their passwords, all of their tokens on their system that were available, and so on. Using the session cookie for CurseForge, the attacker was able to be logged into their privileged CurseForge account without actually needing to log in using two-factor authentication. You see, with only their password, as far as they would be able to get would be the login screen. However, the way that you stay logged into a website using a session cookie was available to be stolen as well, so the attacker could pretend to have already logged in, and CurseForge wouldn't be able to tell. From there, they used the web portal like usual and uploaded a compromised file to several mod packs, and then hid it using the web portal options so that it would be harder to detect.
Alright, so at this point, we've gotten a good understanding of the 4 known stages and the security failings of the Minecraft modding infrastructure that made this infection possible and potentially widespread in the first place. We decided that we had to hold an interdisciplinary meeting to discuss solutions to the problem that this situation uncovered. On June 8th, we hold a meeting with many corners of the community invited. Major modding groups are represented here, including CurseForge, Modrinth, Forge, Fabric, Paper, and Quilt, as well as launchers such as Prism Launcher and groups such as Feed the Beast. An agenda of topics was prepared beforehand, which we'll go over. The meeting was fairly successful and went pretty smoothly. We ended up covering every action item that we wanted to. The full meeting is linked on the slides here if you want to watch a recording afterwards. The general feeling at the end of this meeting is that the parties wanted to put these plans into action to prevent another fiasco like this one.
So, Willie Willis was responsible for collecting, organizing, and documenting the action points and discussion of the meeting. We ended up having 5 main points we wanted to discuss, and those are displayed in order. The first action item: what checks were actually being run by CurseForge and Modrinth? Both platforms have quite opaque checks in place for uploading files, and we wanted to discuss if they were adequate and if more needed to be done. Both platforms committed to extending extra resources to improve these checks. However, there was the general sentiment that most of them should remain private and not discussed publicly, as giving information about how they work could give attackers the ability to circumvent them. The second action item: reproducible builds. While modded Minecraft is a mostly open source community modernly at this point, that doesn't provide as much security as would be desired. There is currently little trust that modders are building the code that they publish and not changing it before uploading. A problem for this is a lack of focus on reproducible builds. Some build systems produce inconsistent artifacts, so if you were to download the code that a modder has published and build the same thing, you're not always going to get the same thing out. So it's hard to tell very quickly and concretely that they're being honest to you. Parties present committed to making sure reproducible builds were properly supported in build systems moving forward. In addition, we also encouraged devs to publish their mods using CI rather than doing it manually, and groups floated the idea of having templates in place to reduce the efforts of modders need to go through to set up CI. CI is beneficial because it lacks the intermediary step of modders manually uploading mods, which could have potentially spread fractureiser, and it also removes some of the ability for modders to be secretly injecting code. The third point is external executables. Fractureiser itself iterated upon downloads via downloading new stages over and over again. So obviously this was a concern for existing mods that have the same process and are hard to vet by distribution platforms, and could change or become compromised without warning. The platforms present did not commit to disallowing this behavior by being used in mods of their platform. However, there was mention of consideration over what groups or individuals would be allowed to do so, citing rapport and trust elements. Fourth is the trust mirror to reproducible builds, code signing. Signed code guarantees it was built by some individual or group, or more generally, whoever has access to the key. Malware present in signed code would clearly implicate whoever signed it, so encouraging mods to sign their code and possibly having a system to restrict certain mod packs or downloads to be only containing signed mods would be a big piece of trust for users, as associating yourself with malicious code is a big barrier to publishing it in the first place. The final point on the agenda was sandboxing. Several people wanted to discuss this, however, there's no solution for sandboxing Java on Windows, so the point was very brief. Some launchers, like Prism, actually do sandbox on Linux from certain distributions, and Sandbox Prism in particular could likely actually prevent a fractureiser infection. However, a majority of players do not use Linux, so while this security is nice to have, it won't scale to a majority of users.
And that puts a wrap on the reverse engineering and mitigation process. It was a wild 3 days of work, but the results of our efforts speak for themselves. Let's move on to the retrospective. Now that everything is safely behind us, we can start thinking about our decisions during this process and come to a better understanding of what we did right and what could have gone smoother. Primarily, chat platform choice for dealing with a rapidly changing situation matters. IRC, in addition to being accessible without signing up or needing to log in, had the benefit of acting as a filter for those not already familiar with technical development, making the atmosphere a lot more focused. The Discord guild that was created, on the other hand, required active moderation and became difficult to deal with almost immediately. This was time that could have been better spent analyzing the samples on hand or improving documentation. In addition, while voice calls increased the speed of collaborations, they were not recorded, so everything mentioned during them, all the ideas people had, are now all lost. On the contrast, full logs from the text chat still remain and are accessible for future reference. In addition, we should have used GitHub from the start. The issues with HackMD and the total lack of access control with Snapita made it difficult to manage at scale. The process involved with GitHub, which we originally thought would be too cumbersome, ended up being to our benefit as the scope of the investigation increased. Finally, it's also important to consider the personal toll of managing a situation like this. Personally, I got like 3 hours of sleep on the first day and like 15 over the 3 days when we were still in the middle of things. It's exhausting work, and even though we prevented countless people from getting infected, it still took a toll on all of us.
Fractureiser, of course, failed. We managed to stop it, but it's worth discussing some of its failings to better understand how we stopped it and where future malware may improve. The most important point is the poor network contingency plans that were used. Stage 0 has a single hard-coded IP address to move the infection to Stage 1. So if that IP ever goes down, like it did early on in our mitigation efforts, no Stage 3 infections that we are familiar with could have propagated to Stage 1. As this was done promptly, the mechanism of infection fell apart very quickly. while further stages contain contingencies, such as the CDN URL to download new CNC server locations. It is confusing why stage 0 does not, as it is the start of infections. Another point, uploading a deobfuscated version of your malware is a bad idea. It helped us confirm what stage 0 was doing and gave us more insight into its workings that we would have struggled with otherwise. It is worth noting that, as far as we know, there were no changes to the unobfuscated malware, so there wasn't even an attempt to mislead us. Moving on, the obfuscation in general was mediocre or not present. Stage 0 was trivially deobfuscated, and Stage 1 had no obfuscation at all. Stages 2 and 3 were obfuscating using Allotory's demo, which had more smoke and mirrors to waste time, but it wasn't very effective in stopping things overall. As another point, the overambitious spread was also very key in its failing. Lunapixel Studios has many high-profile packs that get tens to hundreds of thousands of downloads per day, making it a high-risk, high-reward for malware targets. It would have been safer to target smaller mods and slowly let the malware propagate, though, instead of going for the highest profile packs possible, putting eyes on the malware. It is worth noting that Fractureiser was able to exist for almost 2 months using this strategy, and almost immediately after uploading to Lunapixel Studios, it was detected. And, of course, Fractureiser targeted the Minecraft community, home of Java reverse engineering. If there's one thing that Minecraft modders are familiar with, it's understanding obfuscated code. Minecraft modding is also the source of many reverse engineering and deobfuscation tools in the general Java ecosystem, so there was a significant amount of people with the skill set to pick apart Fractureiser's multiple stages. In the end, Fractureiser, as far as CurseForge has let us know, was downloaded onto 6,500 computers. In 24 hours, it could have been over 100,000 easily.
It's worth taking a moment to discuss the MMPA. During Fractureiser, we mentioned a split between IRC and unofficial Discord users. The Discord guild was set up partway through the investigation against the wishes of many members of the team and caused significant communication difficulties and moderation burden, as well as requiring organizers to take a large role in distributing information. A majority of the core team was located on, and a majority of contribution originated from the IRC, and the documentation only ever referred to the IRC as the centralized contact point. But there was definitely progress and communication done by members of the Discord guild. However, as the events concluded, it became clear that the guild had ambitions past what the Fractureiser mitigation team had. For us, we simply wanted to stop Fractureiser and get on with life. In an effort to make this clear, the Discord guild rebranded moving forward and is modernly known as the Minecraft Malware Prevention Alliance.
Unfortunately, MMPA has used their relative trust in the community irresponsibly. In the past month since Fractureiser, the team behind MMPA has looked into a handful of security concerns in the Minecraft ecosystem. However, their handling and disclosure regarding the security concerns has been less than ideal. A simple criticism to make is that their blog posts and releases are quite unprofessional and sometimes lacking clear information for people who may be impacted by vulnerabilities discussed in blogs and are seeking advice. A more complex situation to discuss is their handling of a vulnerability known as MC Madgadget. If you're unfamiliar, MC Madgadget was a serious, long-standing vulnerability with several older mods impacting primarily 1.7.10 and 1.12, but extending elsewhere, that allowed for completely arbitrary code execution on servers and clients, with the only requisite being connections to a server. This is one of the more significant and hard-to-patch vulnerabilities in the history of modded Minecraft, due to its presence in dozens of mods on older versions, where updates are no longer being produced. While some other teams were familiar with MC Madgadget and were working on mitigation efforts, MMPA became informed of it, and in under 30 hours had published the exploit publicly with inflammatory marketing, dubbing it Bleeding Pipe, a name that has little to do with its function as an exploit.
This is extremely irresponsible disclosure. In software communities, there is serious concern given to the responsible disclosure of vulnerabilities to protect users and give adequate time to patch it, in this case from server hosts or other mod distribution providers. By disclosing exploitable vulnerabilities without mitigation efforts in place, it becomes less of a warning and more of an advertisement that there are systems with unmitigated vulnerabilities to exploit. While this concern was expressed to the people involved, there's been no recognition of this activity being a mistake, no commitment moving forward to understand and take responsible disclosure seriously.
Due to this, we believe it's important to use our time today to discuss this situation and cautious against people putting their trust in the MMPA's organization's responsibility to handle and disclosure security incidents, including vulnerabilities and malware. Off of that bit of a downer note, that's the end of our presentation. So if you have any questions, we are going to be accepting them now.
Yeah.
All right, I'll handle this first question. We can switch off if we want.
Yeah, sounds good.
So the first question we have, I should probably read it before I put it on the screen. Does code signing actually work, or do you just make the malware compromise the build systems so that the signed code ends up containing malware? I imagine it says at the end. That's a good question. Code signing is also a security problem to take seriously. In order for signing to be secure, you need to have your keys be secure, and that ends up being the responsibility of the modders, who could be individually compromised. In addition to signing, using CI can reduce this risk, but it's never zero. However, as it stands, there is no trust in place, and this would be a higher barrier for entry for malware. Nothing is ever truly secure, especially when you're downloading arbitrary Minecraft mods off of the internet.
Yeah. Next one, we have, what does sandboxing mean? Put this one. Sandboxing is typically like preventing arbitrary code that you download from the internet, like Minecraft mods, for example, from accessing your host file system and such.
Yeah. So the idea of sandboxing is that if you run Minecraft in a sandbox, it can't touch anything you have, and even if there was malware, all it could do was corrupt your game.
Yeah.
So the next question we have is, if a Linux user has sudo permissions, would that be enough for permission escalation? Permission, I guess that depends on what you mean. If they have sudo permissions, no. In order to escalate as a super user, you need to input your password. And in this, unless the game or server itself was running with super user permissions, which is extremely uncommon for both servers and clients, then no, that would not be enough for permission escalation.
I heard people were still talking about signing jars. However, I never heard anything more on that. Are there still, I think this says, like, is that still being worked on? I think so, but I think the talks from the like modding platforms and such has slowed down a little bit.
Yeah. All right. So moving forward, we have another question. Has any incident with MC malware like fractureiser happened prior? Let me put this on the screen. If you mean like fractureiser, you mean in that it's in its large scale? No. As far as things have gone, fractureiser is the biggest and most narrowly prevented piece of malware in the community. However, fractureiser does have its origins in the Bucket plugin system, where similar exploits and pieces of malware are being distributed. And also, any malware that hasn't been discovered yet could potentially be leveraging similar things.
Anonymous asks, why was fractureiser in so many stages? That seems unnecessarily convoluted. One of the benefits, I guess, of using multiple stages is that each stage does something slightly different with less code. So it's not like you have the entirety of like all of the stealing code on your hand, like with stage 3. Stage 1 downloads stage 2, stage 0 downloads stage 1, and it propagates itself, so it's easier to hide. And yeah.
Yeah, Jasmine, this next question I'll put up, but I think we'll kind of skip it. It says, is there any reason the malware tried to infect other jars with stage 0 rather than directly with stage 3? And yeah, it has a lot to do with the obfuscation factor there. Stage 3 is very large, and having it show up in a mod would significantly increase file size and would be way easier to spot. Stage 0, in comparison, is very slim and makes very little profile as it ramps up on a system. So I guess we'll go on to the next question, which I think I have a good answer for, which is, why list out how fractureiser failed? Couldn't others use it to make their virus better? So yeah, that's actually a really good question. The reason that we list out why it failed is not to help people who want to create further viruses, but rather to caution the current systems. Its failings is what helped us prevent it, but had those not existed, what could we have done? Moving forward, it's important to see this and recognize that more security needs to be in place. In regards to helping people make their virus better, if someone doesn't have the ability to look at fractureiser and understand what its failings are already, this presentation wasn't going to help them write better malware.
This one says, if MMPA isn't great, then where should people be getting notified of potential malware? Typically, there's, for example, with MC Mad Gadget, there was a different group that did a lot of the uncovering by themselves. So it really depends on the situation. No, malware situation, no exploit situations going to be the same. So this is a very it depends sort of answer.
Yeah, and I guess I'll add on to it. As it stands, there's no centralized source that I would call trustworthy for gathering malware information. You'd have to stick to your typical channels of information distribution and hope that users are spreading the news as fast as they can, unfortunately, at the moment. So the next question is about jar signing. It's, could someone sign code under someone else's name? No, signing isn't necessarily name-based. It's based on cryptographic keys. The way that you sign a jar is having access to the keys and using it in the build system to perform a transformative process that can only be done by people that own the keys, but can be validated by anyone else. So I guess the answer is actually yes, someone could sign it under someone else's name, but they would need to have access to the keys, which is private information, and the disclosure of that would be a leak of vulnerable information and would have to be invalidated by hosting providers.
Anonymous asks, would either Discord or IRC work as long as it's centralized? So I would have to say that IRC would probably work better, because with a Discord guild, you have multiple channels, multiple places to put things. Typically like an announcements channel, like something for people to file into and such. But IRC, you get a topic, you get the chat, and then that's kind of it. So it makes everything there, and it makes it very easy for people to come in, ask questions, and then just watch people work and become get in the know that way.
Yeah, I'll concur with what Jasmine said here. I think it is way better for staying on topic and staying focused. But the crux of this question, would Discord work if there was only a Discord? Yeah, it probably would work. A majority of the issues that we had was the fact that the Discord was created after the IRC and then split efforts and caused great communication burden that a lot of the organizers had to take on. Ultimately, IRC was the better choice here, especially for malware distribution and disclosure, but a Discord could have worked. And especially if it was designed in a way that tried to reduce some of its problems, I'm sure it could have been fine.
Yeah, as an example, the Vineflower Discord guild has this the setup where we have a Discord guild with one channel that is a link to both an IRC chat and a matrix space, and I think it works fairly well. So it could work, but it requires a lot of setup, and it's just better to use IRC in this instance.
Yeah, we have a question from Willie Willis, which is a bit more personal. I think that both of us would individually answer, but it's, what MC projects or new features for them are you working on next? This is, I assume, unrelated to fractureiser. I personally am still working on EMI. I have a handful of feature updates that I would like to push out that improve things like how the recipe tree works and improve other things like how searching works, where you can position search bars, and improve the customization for the sidebars and stuff like that. I have some other things, but I like to keep things on the down low so I can surprise people when they come out. Jasmine, how about you?
I'm currently working on going to my bed and sleeping.
I will agree with that one.
Yeah, there's some stuff that I'm working on, but not much. Burnout and such. If there's things that I'm doing, I will probably post them in places that you could see. So, yeah.
Yeah, I didn't mention it when Jasmine talked about it earlier. She said she had gotten 15 hours of sleep. I believe I got a similar amount of things over the 3 nights that fractureiser was going on. I almost feel like I still haven't recovered. This was multiple months ago, but definitely with the stress of Blanketcon, there was a lot of work to organize these presentations and the con itself. I wasn't involved with con organization, but yeah, I'm very excited to sleep. I'll see if I can put that in a Minecraft mod.
True. Yeah, the war against the MSPT has been it's been going well. We won. I am so tired. We should move on to the next one.
Do you want me to
How do
do
you? Yeah, go ahead.
Sure. How do you think the chances are that a majority of launchers or mod loaders implement useful security mechanisms in nothing? I say in them. I'll put this on the screen. I think the chances are decent. As it stands, it's been several months and nothing significant has occurred. And I guess part of this question involves the security methods being put into place in the first place. Probably the easiest and most tangible form of this occurring would be a centralized certificate authority organized by both Modrinth and CurseForge, through which modders could sign their mods and have this displayed on the site that they are known to be created and uploaded by the authors that created them. As it stands, this does not exist, and without it, launchers and mod loaders cannot integrate that into their systems. More incrementally, a lot of the other solutions involve modders improving their build systems, and it would be the sort of thing that can't really be verified by launchers or mod loaders, like using CI or reproducible builds. If you have any other comments, Jasmine.
No, I think you covered it. For the next one, Taterblight asks, what can the average user do to help groups like this crack cases? Knowing the risks of intentionally downloading viruses. It's cut off here, but yeah. I guess like with stuff like this, we had a lot of people working on the actual deobfuscation, but we didn't have a lot of people working on giving out good information to people that aren't in the know. A lot of people were panicking. I think we searched fractureiser in YouTube a couple days after everything happened, and it was kind of funny at first, and then became kind of sad because everyone was giving out very bad information. So like information proliferation, in situations like these is kind of important, and like if it weren't for like Vasky giving out very helpful information on Twitter, probably would have been much more convoluted.
Yeah, I guess to more directly answer it, like as an average user, what can you do? You could try to educate yourself as far as you can know, as close to the source information by those doing the investigation, and trying to, in spaces that you're in, reduce misinformation and spread true information. I think this is a pretty low technical requirement, but it does require being able to gauge who is trustworthy and who is not. Jasmine, do you have an answer to this next question?
No, I do not.
We'll show it for anyways, but it's would NixOS with temp fs mitigation, or temp fs mitigate fractureiser. I don't know. I don't use NixOS. I'm not sure how it works. The name suggests temporary file system, but fractureiser can run in one instance. The startup script is not necessary for it to proliferate to stage 3. So if that is the information required to answer your question, then there you go. If it's not, then I don't believe I have the technical knowledge to continue. So I guess we'll skip this one and go to the next one. This is from IMMRP, which is there any info as to where exactly fractureiser actually originated? I guess there's two different ways to interpret this question. The first is, where did fractureiser, the virus, originally become uploaded? And it seems to have been targeted with certain Bucket plugins a few months before we initially realized that it happened. If you mean more personally, like who created it and what were their goals, then no, we have no clue. And in fact, we had no desire to attempt to find out. There was exactly one rule during the entirety of the IRC, which is you cannot discuss potential leads into who did this or try to discover it. This might seem confusing, but there's a really big risk if you do anything like this to incite harassment campaigns or get to the wrong conclusion. As software engineers, especially reverse engineers, we may be inclined to believe that we are good at what we do, which is hopefully true. But what we do is software engineering. It's not deducing the motivations and sites of, personal relationships and such like that. So we decided to leave this up to the authorities if they want to pursue it, and we have our publicly available documentation that can be utilized by this. Jasmine, do you want to speak on this?
Yeah, identifying actors doesn't really help anyone. It's not helpful for preventing the situation on hand, mitigating it. With the amount of eyes that we had to be responsible, and so the only rule that we had during the whole thing was do not identify actors, don't even talk about it, we don't care. It's here, we're gonna try to fix it.
Yeah, you want to take the next question?
Sure, but I don't recall if we talked about this. It says, was Win32 app isolation explored for sandboxing on Windows? I think there was some talk about app isolation, but unfortunately, I don't remember all the details. Emmy, do you happen to know anything about this?
I'm not super familiar with this. IMS in the chat is saying it's not usable before Windows 11, but I'm not sure if it's actually usable in the modded Minecraft ecosystem. As it stands, mods are unsigned code. They're not actually apps, so I don't know if this would work. So I guess the question is, it's outstanding, we're not sure. The next question is, how did Stage 3 get into other mods? This may have been a communication issue. Stage 3 is not present in any mods. The only instance of fractureiser that is present inside of mods and on sites is Stage 0. Stage 0 is what downloads Stage 1, is what downloads Stage 2, is what downloads Stage 3. It's an iterative downloading process from the internet, so yeah. I guess in the chat, I think they meant, how does Stage 3 put Stage 0 into mods? It just iterates the file system. It looks for jars. You can look at the code and be like, is this a Minecraft mod? Does it reference these classes? If so, put it at anything that implements this, or just put it at the main. It is fairly trivial to use ASM utilities to do this, and yeah, so that's what they did.
The next question from Stony Hoof says, I'm sorry, but I missed my question being read. Could you please repeat your answer? Which question was that? You'll have to type it into chat.
It was was an incident like fractureiser happened before?
Yeah, I'll repeat my question, or my answer to that then. As far as we know, to this scale, no. Has there been malware before that, does stuff like this, that tries to steal tokens? Yes, probably. It's been more prolific in the Bucket plugin community rather than Minecraft modding specifically. But fractureiser in scale and with the response that it had, especially congregating groups of interest, is by far the biggest incident of anything like this that we've had. Do you want to read this? Or
I think you should do it.
Okay. Does the MC modding community have a preference between signed jars or digital signatures released with builds? The MC modded community has a preference to do neither at the moment. So either solution would probably be fine. I think the upside with signed jars is that it's a single artifact and it might work better with existing systems, but No preference. We have nothing as it stands.
Yeah. We have a question from Amy. Would you agree that the inaccessibility of IRC compared to Discord is an advantage to keep things quieter, and it gets cut off? But I would guess I would say for this specific case, yes, just to keep things quieter and more like reverse engineering and development focused. Yeah. Emmy, do you have any thoughts?
Yeah, I think this is definitely a big advantage for situations like this. Inaccessibility as a word is, it sounds like a negative, and it is in most situations. I wouldn't tout IRC as the better way to have, communities and discussions in general. But for the fast iterative process of malware reverse engineering, especially in this instance, the inaccessibility means that the people who join are the people that either already understand IRC and have a much higher chance of being technically knowledgeable, or those who have enough technical background and are willing to go through the process to get over the small hurdles to get into the process.
Yeah, I would agree.
Next question. Do you think it would have been discovered if Lunapixel wasn't compromised, like if it just kept spreading slowly through mod to mod? This is an interesting question because the answer is technically it already was discovered. We mentioned where we got the stage 3 artifact from was from someone who had already been infected initially and was going over some minor reverse engineering efforts. They hadn't gotten very far, but they did have all the artifacts and were a very big help in contributing to the team as it was happening and delivering us the artifacts. Something they did do was communicate with CurseForge, I believe. I don't know if they communicated with anyone else, and disclosed this vulnerability of the mods. As far as we know, CurseForge didn't respond, or if they did, it was slow and silent. But given enough time, someone had already noticed it. I'm sure someone else would have. It was good for us that the Luna Pixel Studios event happened because it did mean that we were able to stop it earlier. But it's also worth revisiting the fact that the server that hosted stage 1 and stage 2, hosted stage 2 and stage 3, which was downloaded from stage 1 and stage 2, wasn't responding when we began our investigation. It's unclear if this is because it took me in particular, I don't know if it was half an hour or an hour, to get to the point of knowing what to do to install it, and they had black holed it to prevent analysis, or if it had just broken on its own. But if it was already just broken, then the virality was already stopped, and we may have had more time.
Yeah. I think we're over time, so
Yeah.
we'll have to cut it here.